So you are in a top MNC system design interview, and let's say the question comes in design Amazon or design any e-commerce website, right? How would you answer it? Typically, in an interview, you would have 60 minutes, but let's say there are 20 designs out there, and you have to revise all of these, right? So how would you revise? What is the best way to revise? So this is exactly what we are going to discuss in this video. Welcome everyone to the channel. If someone is new to the channel, I'll just give a quick overview of who am I and what this video is going to be about, what this channel is going to be about. I am a Jagrit and or elegant engineer. I have total 4 years of experience and I currently work at Microsoft. So last year when I was preparing for Switch, I was fortunate enough to receive 10 job offers and I have more than 2000 plus lead code rating. And also I have given more than 100 interviews out of which 20 were HLD interviews, right? So that's what we are going to discuss in this one. If anyone is watching this first time, I would suggest watch at 1.2 or 1.5x speed for a better experience. And also, if you have any questions, feel free to join Everyday Live, which occurs at 10:30 p.m. IST, to discuss any problems or any things that you're facing. With that, let's get started. So this is a episode 3 of System Design Unleashed series. Why I call it Unleashed series is because in this I am going to discuss how you can design Amazon, or in the previous I have discussed Instagram, Twitter search in 20 minutes, right? With the aim of why 20 minutes? Why I have specifically written 20 minutes? Because when you have learned so many designs, you have watched 1 hour, 2 hour videos, right? It is always tough to kind of revise them when whether you are giving an interview or let's say whether you are watching, whether you are eating lunch or whether you are at gym, you can just listen to this as a podcast or as a video, right, which will kind of give you revise all of your design concepts. So that is the aim. I have watched part one and part two to revise myself. So that's the aim. Just a disclaimer, this video covers high level approach and the optimal design we will come to, but we will be discussing all the pros and cons of various approaches, right? So stay tuned, watch till the end. If you have any questions, let me know in the chat. Okay, so with that, let's get started. So as I have given so many interviews, right, I would like to highlight one of the things. So whenever you are in an interview, right, whenever you are in an interview of system design, ideally what you will be asked is your interview will revolve around these topics, whether functional requirement, non-functional requirement, capacity estimation, database design, API design, high-level design, component deep dive, CRIPS. And CRIPS is something that I have created, but it's generally resolves around scalability, right? But in the rapid fire system design, which we are going to do now, we are going to be discuss functional requirement, non-functional requirement, high level, and then we will do a component deep dive, right? Because these things are something that will be unique. Capacity estimation, API designs, these will be very much similar to all of the systems out there, right? So you don't have to revise these things again and again. The crux of any system lies here. Who should watch this video? Anyone who has done engineering, who is either working or who is preparing for interview. This is going to be the best 20 minutes spent. So if you watch at 2x, this is going to be the best 10 minutes spent. So with that, let's get go to our design Amazon in 20 minutes, right? So first of all, so we are going to discuss Amazon from a buyer's perspective. We are not going to discuss it from a seller's perspective. We will be talking about buyer. So let's think of the functional requirements, right? So user should be able to browse and search products. Whenever we open Amazon, user can browse and search for products. User should be able to view the product details. So once you have clicked on a particular project, you can see the product details of it. Users should be able to add and update their carts. So we can add and then we can add a particular quantity also for that element. And then users should be able to place and pay for the order, right? So these are the main functional requirement. So you should discuss this with your interviewer and then decide which one uh, he or she wants you to prioritize, right? Ideally, what I would say is these first two and then this checkout is what I would prioritize if I have an interview. So this is the seller perspective, and then this is the admin perspective. I don't want to go into these details because it's from buyer perspective in this interview, right? And then, so this is what the system should have basically, right? And how system should perform. That is the non-functional requirement. So we'll be discussing that now. Now, again, I have taught this in my previous videos also. This is a very popular concept of DSA, but in the same way, I have customized it to use for scalability, right? So here, LCS, DFS are really like a popular known concept. LCS is longest common sequence, and then DFS is depth first search, right? Now you'll see how we are going to use this here, right? So L stands for low latency because in an interview setting, right, it will be really tough for you to come up these all the different aspects. So these keywords will going to help you. So first think of low latency. Where do you need low latency? In this system, we need low latency for our browse and search. So when we click on a product, so the request should happen really fast. When we search for any query, that also should be fast, right? So results should be shown quick. So this you don't have to write, but this is something that you should write on the whiteboard. Then the another aspect is C here stands for cap theorem. Now cap theorem says that out of availability, partition, and then consistency, you can only have two. Again, I'm not going to explain these terms. This is not meant to be explanation. If you want to learn, I think I have already mentioned. I will also mention the resources like there is a very good LXU book. There are a lot of good channels like Code Karle, Hello Interview, Byte by Byte Go. All of these channels are good. Watch them, read books for detailed deep dive, right? Now coming to our availability, right? So here our browse feature should be highly available. It should not be like that if I'm searching on browse instead of showing me anything, it is just giving error out, right? It is okay to show the stale products, like that is okay for a minute. If let's say our all the nodes are not updated, we can show the stale data, but we should not say that okay, no error, right? Error should not be there and highly consistent for checkout, right? So there should be no double orders. It should not be like that. There is only one iPhone and you have also bought it. I have also bought it, right? That should not happen. Let's say Messi has also bought it. Ronaldo has also bought it. So who's the iPhone going to do, right? Now then comes the scalability. So millions of products will be there, flash sales, millions of orders will be there. So our system should handle all of this. So this is LCS, latency, cap, and then scalability. Coming to DFS, right? DFS is durability, fault tolerance, and security. Generally, these are extra. You don't need to go into much details, but one durability is important. It's like if I place an order for iPhone, you can't come and say that, okay, we did not get your order. These kind of things should not happen, right? So that's why this is important to mention, but I would not like spend too much time on this, right? Now, after that, ideally you would design your entities, you would design your database schema, but that is very straightforward, right? So we are not going to go into the SDCs. We'll straight away jump into high level design. And this is also important. Like I have given so many interviews, I've seen that some of the interviews they directly ask you to jump to the design because they don't want to waste your time on other things, right? That's what we are also going to do. This don't be overwhelmed by the design. We are going to do look at these things one by one. Don't get overwhelmed, right? Let's discuss one by one thing, right? So the first thing was users should be able to browse or search for the product. So we have this product. So product is our entity, right? So anyway, Amazon is a big service, right? It's not a something that can be designed in a monolith. So one of the principle that we would be using is that we'll say that okay, we are going to go with the microservice architecture. So first thing, so Messi is using our Amazon app. Let's say wants to buy some iPhone. So he iPhone 17 has released and he wants to buy the iPhone. And we are fortunate enough that he is using Amazon app, right? Now, what happens first? So he opens the app. Now he browses for a product. He already knows that, okay, let's say iPhone 17 is coming on the scene. He will just assume that. He clicks on that and he wants to choose the color. So we are at the iPhone 17 page where he can see the product details, what are the reviews and whatnot, right? So that is our blue point. So just concentrate on the blue endpoint. No need to worry about all the other things mentioned here. Again, watch at 2x. That way you would learn things faster. So what is happening? So we have API gateway first. API gateway's function is just like a traffic control system we have. It will direct the request to different microservice based on the request, right? If it is a view product, it will go to product service. If it is a search, it will go to search service. If it is a place order, it will go to cart service. Don't worry about these things. Imagine that you only have a product service. Now, what is going to happen is you have a API gateway, you get this product, and this product service is storing products in a product DP. Now, here is an important choice. which DB are you going to use? Are you going to go with the SQL or are you going to go with a NoSQL? Now here, right, one of the important factor that we have is that our products can be of different types, right? Like let's say if it is iPhone, then iPhone will have different colors. iPhone will have like what kind of GB it is, all of those things. Now, instead of if it is a cloth, right? Cloth can also be sold on Amazon. Let's say if it is a shoe, right? Now, shoe will not have GB, right, in it. So that's why different, the schema is kind of flexible here. So whenever the schema is flexible, I would suggest that we can go with NoSQL database. And for this, we don't also need any ACID properties. So ACID properties are not required. So that is another thing that we can basically conclude that, okay, we will go with NoSQL. So we will choose MongoDB here. If you are experienced with Amazon, you can use Amazon DB, right? Now, so for what will happen, basic simple flow. So we'll get a product with its ID. It will go to product service. Product service will fetch the data from here and then return back to it. Now, if let's say there are so many calls for iPhone, so you can also place a cache here so that the request goes through cache, right? That is another improvement that we can make to the design. But the flow of watching a particular project or watching a particular product is very straightforward, right? So that's done, right? This should be good so that you have established some basic microservice, get the ball rolling, right? Now coming to the second part, search with the keyword. Now here what is happening is that Messi has just typed iPhone. He is not sure or he has just typed phone. So our aim is to show him both Samsung and iPhone, right? As of now, he has not decided which way he wants to go. But personally, Messi uses iPhone, so he'll probably go in a iPhone way only. But let's say he just typed phone. Now, naive way would be that, okay, search, we have a search microservice, it goes to this microservice, and then it calls this product service, it basically looks all the products, or it can also directly go to product service. In a naive way, it could go from both the ways, right? Either search service could get all the products and then do a scan, or we can say that in naive, it directly goes to product service, and then product service scans through all the names or descriptions and then looks for your then it will look for all the names which has iPhone it, or maybe on the category it will see that okay, this is iPhone category and then fetch that. But the con that we can see is, right, it is a whole DB scan. This whole is going to scan the DB, right, which is a very costly operation. So we don't want to do that. So we can conclude that we have millions of product. Naive is not going to work. So that's where we want to use a concept of Elasticsearch. Again, if you have not heard of it, in the Twitter search, I have completely ignored Elasticsearch and I have just implemented own indexer. But here, this is not the crux of the problem, right? So we can leverage Elasticsearch. Now, what basically Elasticsearch does is it uses inverted index. So let's say if we have iPhone and all of this on the iPhone keyboard, it will do the mapping, right? Again, if you want to understand Elasticsearch in detail, I would suggest just Google Elasticsearch, watch a couple of videos around it, or watch the episode 2 of this. In that we discussed in detail. This is episode 3. Watch episode 2 in detail, right? That will tell you how Elasticsearch works. But we are going to do Elasticsearch. So now how the flow is going to happen is, so whenever let's say a new product comes in, right? So we will be adding a topic to Kafka because we want to make this a asynchronous flow. As I mentioned earlier, little bit of latency or little bit of staleness is okay here. So I don't need to just put a API call that, okay, product will call API service or product will call directly the database that this search service is going. No, that's not going to happen. We want to make it asynchronous. We can take couple of milliseconds. We can take 500 milliseconds. We don't want to put extra load, right? So that's why we are going to use asynchronicity in our system. So what is going to happen is, so in this design, I have just taken a reference also. So the product service here, it will come in and then add a event to a Kafka. The event could look like this. It could be product. I have generalized it to product, but it will have like iPhone 16 and then what is the price of it and then its electronics and then what is the GB and color of it, right? This is something that is going to go to our Kafka. Now, after once we have added this, right? Let me quickly refresh. So once we have added it, so what is going to happen after that? Now, once you have added your it to a Kafka, So now again we can have multiple approaches, right? So Elasticsearch is it's kind of a DB only. It's a search optimized DB. You can do better search on this. This is not stored like that, so we are not using it for product DB. So what is going to happen here is couple of ways. Either you can have a custom indexer, right? You can have a custom indexer that is going to pick this event, going to transform it and put it into class Elasticsearch. But there is another concept, Logstash. So Elasticsearch is generally used as ELK. Elastic stands for E, and Logstash stands for L, and K is Kibana, right? So Kibana we are not going to discuss, but Logstash, what it basically will do is, right, it will pick the data from this Kafka and then it will put the data into Elasticsearch by doing some out of the box conversion on top of it, so that the search is easy on those, right? Now our search service is very straightforward. So the request comes to this search service. We are going to directly look for that keyword iPhone 15 in this Elasticsearch DB, and then we are going to give back the results to Messi, right? And let's say if the query is very super hot, right? In this, the query is like you have iPhone 16, which is like a very super hot. Everyone wants to get an iPhone, right? So for that, we can cache the results also. Like for this search iPhone 15, these are the products. So we have two products. We will just directly return from this cache. Now cache will be in memory of this service. Although in the diagram it looks like it is outside, but consider this is in the system only. This is another server. This is in this search service only. So if the search service goes down, then basically your cache has also goes down. That is the meaning of in memory. Again, guys, if you don't know all of these things, you can probably look at it, right? You can probably learn these things in detail. So that covers our search functionality. So Messi search for iPhone, it will go to this search service. It will do a query on Elasticsearch. This Elasticsearch query could be a normal Elasticsearch query, right? And then this will give you some results, and then we'll display that to the user. Now here, one more thing, I am only returning the product IDs, right? So instead, what will happen here is, so once you have got the product ID, you are going to call this product service to get images and all those stuff, right? That responsibility is with the product service only. We are not going to bring that responsibility to search service, right? Cool. Now, basic things, something else also we need. Let's say we have a cart. You added couple of elements to cart. Cart is very straightforward. How the cart data is going to look like is that we are again going to use MongoDB only. Let's say one document per user because you only have a one cart, one cart. So you have this user ID, right? And then you have items, right? Item will have just a product ID and whatever quantity you have, right? You have added those to your cart. Now I am not discussing about whether that element is available, because once you add it to a cart, generally when you click on place order, right, that's where a quality check also happens. You can do this before that also, but ideally I've seen in Amazon it happens once you place the order also, right? And then gets the message, oh, one of the element is missing from your cart, right? It could happen asynchronously also, but we are going to, for now, we are not going to make things complex. We are just going to say this once the user is trying to do place a click on order, then we will going to do that check, right? So this is a straightforward card service. Now, let's say user wants to place an order, right? What is going to happen is the call is going to come to our order service once the user clicks on is in this payload. There can be your whole card can be sent to this, or it could be just product or item. If let's say you don't go via card route, you just place order, right? So both ways the query could come into it, right? But what the order service would have is it would have something like this order, and it will have order ID, user ID. User ID we are not passing via payload because it will be passed via JWT. So it will go to this order ID, and then order will have its status, amount, and audit, and then each of the order item will again have its order ID, what is the product ID, and what is the quantity of it, right? And let's say a question comes to you, how you are going to split this, right? Let's say you have millions of order, right? Every day millions, and then you have billions of order. But the database cannot scale, right? That's why you are going to shard it based on the user ID. So all the orders of a particular user will be on a particular shard only. And here we will not feel any hot celebrity problem. So user ID is okay. If you don't know about celebrity problem, please feel free to search about it, right? Or you can let me know in comments. I am happy to answer those. Now, what is going to happen in this order service, right? Now, first we need to basically do a availability check, but we never discuss who is going to maintain the inventory, right? That's where inventory service comes into picture. Inventory will just have its product ID and what is the quantity that is available to us, right? We could have whereas Saudi different, but keeping things simple here. And now this is going to be SQL. Like I have not mentioned specifically here, but this is going to be SQL database because we need acid properties. We don't want to do acidity from our side. We want out of the box acid functionality. So that's where we are going to use inventory DB as a SQL, right? Now, what is going to happen? Let's say Messi is now going to place for two iPhones, one for himself, one for his wife, right? So he wants to place iPhone for two, right? Now, what is going to happen is he has selected iPhone, but we will check whether 123 iPhone, this is the product ID of the iPhone, whether that is available, right? So first we will do availability check. We'll come to here and then we will check that whether the availability counter is greater than equal to 2, right? If it is, right, then we are going to reserve that stock. That is the second operation. And this is going to be atomic, right? I have also pasted the SQL query, how it is going to look like. You are going to reserve that quantity and you are going to decrease the available quantity, right? You are going to decrease the available quantity so that Ronaldo, if let's say there are only two iPhones and Messi has already clicked on placeholder, Ronaldo also clicked just a fraction of second later, but we would have already reserved the quantity for Messi, right? So in this case, you don't want both of them to place the order, right? Now, let's say we reserve the quantity. What happens after this, right? After that, the request will go to this order service has marked on the inventory that please reserve it and it will initiate the payment request. Payment again, this is not the crux. Payment, let's say payment is outsourced Stripe. We did the payment via Stripe. And then once the payment was successful, there can be two options. Success in the Messi paid it, right? And then a event has been here and then order service will read the event and then from this we can send out the notification. That is one approach, right? Now, question comes here like why I have used Kafka here. One way could be that payment service could just return the webhook, right? Why not payment service just returns the webhook? But that's where this comes into picture. That is the importance of this. See, this event can be outsourced to multiple things. Let's say if I use the webhook approach, then I have to webhook this also, webhook this also. But better is that I just put an event here, right? Then everyone can read that event, right? This can also subscribe to that event. This will be like a producer consumer. This is producing, and every notification service is also listening to it. Order service is also listening. If let's say it has failed, then notification service will say that order failed. If it has passed, then it will say that order passed, right? And then this is the normal order service, right? So you will update. But let's say if it has failed, then we have another step of rollback. So basically, you have to roll back, you have to increase your inventory count, right? Whatever was the quantity that you had booked it, you have to increase the available quantity so that now Ronaldo can place in. Think of it like that. Messi took 2 minutes to place the order. For those 2 minutes, we had blocked the quantity, but unfortunately, he was out of money, which will never happen. But for some reason, it hit payment failed, right? Maybe Stripe was down. So payment failed came in, and then that time we would release the quantity. So this is very much common with H&M and all those portals also. If you place if you place a t-shirt order and if your payment fails, right, you'll see that the t-shirt is out of stock for some time, but after a couple of minutes the t-shirt again comes back. So this is how the Amazon design would look like. I have taken 3 to 4 minutes more, but in the starting I was giving an overview also. But I would say that if you want to do a quick revision, this is the best thing. But if let's say you are in an interview, you are first time doing it, do want to do a deep dive also, feel free to check other channels, feel free to read books that I have mentioned. All the best. If you like the video, if you have any suggestions on the Rapid Design System series, let me know. Thank you guys. Have a nice day. Have fun.